In early 1942, the Pacific Theater was chaos. Japanese convoys moved through the Bismarck Sea with impunity. Allied bombers tried to stop them and failed. The U.S. Army Air Forces had aircraft with range, payload, and durability, but none that could kill ships. The B-25 Mitchell, designed for level bombing from 20,000 feet, 6 to 100 millimeters, could drop a pattern of explosives across a city block. Against a moving convoy, it was almost useless. Every mission returned the same way: burned fuel, empty bomb racks, and photographs showing ships still afloat. Navy pilots called them medium-altitude spectators. In New Guinea, where supply convoys fed the Imperial Army's island campaign, Japanese destroyers cruised under daylight without fear. Major Paul Irvin Gunn, known to everyone as Pappy, watched it happen from a muddy airstrip near Port Moresby. He was 44 years old, twice the age of most combat pilots, a civilian engineer who had built his own airlines in the Philippines before the war. He had been captured by the Japanese during the invasion of Luzon, escaped, stole an aircraft, and joined the 5th Air Force as an informal technical advisor. Gunn's uniform never matched regulation. His mechanics called him the old man with a wrench. He called himself a troubleshooter, which meant he modified anything that didn't work, including government property. The B-25 bothered him most. It was fast, stable, and tough, but doctrinally neutered. Headquarters wanted high-altitude precision. Gunn wanted low-altitude violence. He had watched too many bombers miss convoys completely, watched Japanese gunners reload before the next wave arrived. The Army Air Forces considered ship strafing reckless. Gunn considered it logical. You can't hit a moving target. From 4 miles, 6 kilometers up, he told one pilot. You have to smell the ocean. At night, he sketched ideas on scraps of maintenance forms, gun placements, ammunition feeds, weight calculations scribbled between notes on fuel leaks. He imagined a Mitchell stripped of its Norden bomb sight, the glass nose replaced by steel, 50-caliber machine guns mounted where bombs used to hang. To most officers, it sounded insane. To mechanics who had seen what he could do with scrap metal and a welding torch, it sounded possible. Gunn didn't wait for permission. In January 1943, he walked through the maintenance hangar at Townsville, pointed to a battle-worn B-25C and said, "That one." Within days, its nose section lay open on wooden trestles. The bomber that doctrine had failed was about to become something entirely new, a gunship built not by engineers in California, but by an outlaw in the tropics. No one knew it yet, but the conversions that began on that humid airstrip would rewrite every manual on air-to-sea combat. And the Japanese convoys that ruled the Bismarck Sea were about to learn that the old man with a wrench had found a way to make bombers hunt. Gunn's modification started with one question that headquarters never asked. What happens when a bomber stops dropping bombs? The B-25 Mitchell had been born from theory, not experience. Designed in 1939, it represented everything the U.S. Army Air Corps believed about warfare before Pearl Harbor: high-altitude precision, formation discipline, mathematical targeting. Bombers flew straight, dropped on coordinates, and let numbers decide victories. The idea looked perfect on diagrams drawn by officers who had never seen a convoy fire back. By 1942, those diagrams were killing crews. Japanese shipping lanes stretched from Rabaul to Leh, nearly 500 kilometers of ocean, guarded by destroyers and fighters. The Army Air Forces sent B-25s against them, flying at 12,000 to 18,000 feet, $3,600 to $5,500 M. Bomb bays released their payloads through cloud and flak, relying on the Norden bomb site's promise of 75-foot under 23 mm accuracy. It was a lie. Actual combat data told the truth. During the first 6 months of 1942, 178 B-25 sorties against maritime targets in the Southwest Pacific destroyed just 7 ships, the average hit ratio, less than 3%. Japanese convoys adapted immediately, zigzagging during attacks, laying smoke, timing turns so bombs fell into white water instead of steel hulls. The Navy's dauntless dive bombers, operating from carriers, achieved better results, but only when they had sea room, clear weather, and surprise. Land-based bombers had none of those. They fought from short airstrips carved into jungles, under constant harassment from Zero fighters based at Rabaul. Every minute in the air burned fuel they didn't have. Every attack profile exposed them to anti-aircraft fire that grew more accurate with every mission. In March 1942, 1/5th Air Force Squadron sent 12 B-25s against a Japanese convoy near Salamaua. They dropped 144 bombs. Only 2 struck their targets, both glancing hits that failed to sink either ship. Of the 12 bombers, 5 were damaged, 2 crashed on return. The convoy delivered every ton of supplies intact. Colonel Roger Ramey's headquarters in Brisbane issued new orders: maintain altitude, refine coordination, increase bomb loads. None of it worked. Gunn read the reports and felt his anger rise. The men who wrote them lived behind desks. The men who flew them died over water. To Gunn, doctrine had become superstition. He'd spent 20 years maintaining aircraft, running engines to the edge of failure, understanding the difference between a blueprint and a battlefield. Airplanes are tools, he told his mechanics. You build them for the job, not for the rule book. But the rule book ruled everything: the chain of command, the depot supply lists, the very idea of how a bomber was supposed to fight. A B-25C carried a 3,000-pound, 1,360-kilo bomb load. The bombs sat in the bay like ballast until the target appeared, then fell in patterns designed for factory roofs. Against ships maneuvering at 20 knots, 37 km/h, most missed by entire ship lengths. Gunn calculated what could fit in the same space: 10 Browning 50 caliber guns, plus ammunition, plus electrical feed lines. The numbers worked. The weight difference was negligible. The only question was stability. Every pilot in New Guinea knew that strafing ships at mast height was suicide. A B-25 weighed over 10 tons. Its wingspan was 20 meters. One mistake and it would plow into the water. But Gunn also knew something else. Japanese anti-aircraft gunners couldn't track targets flying below 100 feet, 30 miles per hour. Their fuses were set for higher bursts. The closer the bomber flew, the safer it became, if it could hit first. The problem wasn't courage. It was geometry. A bomber, built to drop explosives from altitude, couldn't sustain the recoil of multiple heavy guns. Its nose structure wasn't rated for that stress. Every engineer at North American Aviation would have said so. Gunn had no interest in their opinion. He'd seen a pattern in the after-action reports. Bombers that descended for low-level runs often scored near misses, sometimes even direct hits when bombs skipped off the water. It was accidental success, born from desperation. He wanted to make it deliberate. A bomber that didn't release bombs, but bullets. A machine that would fly level, strike fast, and tear convoys apart before they could fire back. Official doctrine said the B-25 was a medium bomber. Gunn decided it would become a gunship. And on the night he tore open the nose section of that worn-out Mitchell in Townsville, the failure of doctrine stopped being theory. It became scrap metal on a hangar floor. The next morning, he started building the aircraft that the manual said could not exist: Paul Irvin Pappy. Gunn's story had never fit into any official biography. He wasn't a textbook pilot or a by-the-book officer. Born in Arkansas in 1899, he had enlisted in the Navy before the First World War, learned aviation the hard way, and built a career around solving impossible problems with what he had. After his discharge, he went to the Philippines, founded Philippine Airlines, and lived like an engineer with wings, designing, fixing, and flying anything that could carry passengers. When Japan invaded the islands in 1941, Gunn's family was captured. He escaped, stole a Beechcraft transport, and flew through anti-aircraft fire to reach Australia. Every surviving pilot in the archipelago knew his name. The Army Air Forces gave him a commission, not because of his rank, but because they needed his mind. Gunn became the 5th Air Force's unofficial technical conscience. He solved problems that logistics couldn't, rewiring radio systems, reinforcing bomb racks, modifying fuel lines. When mechanics said, "That's not regulation," Gunn said, "Neither is dying." His tent near Townsville filled with tools, stolen parts, and aircraft manuals annotated with profanity. What he lacked in authority, he made up for in proof. Every modification he touched worked. The B-25, though, was personal. He had flown it, repaired it, and watched it fail over and over. High-altitude attacks meant the bombs fell hundreds of meters from target. Even skip bombing, releasing bombs low enough to bounce off the water, depended on perfect timing and luck. Gunn wanted certainty, not luck. The idea came one night after an inspection of returning aircraft from Port Moresby. Several B-25s had come back shredded by flak, but the fuselages were intact. The damage was concentrated in the nose, the most vulnerable point. He studied one wreck by flashlight, ran his hand over the twisted aluminum where the bombardier's station had been. The structure was thin, designed to hold glass and optics, not armor. A thought formed. Remove the glass, plate the nose with steel, fill it with guns. It wouldn't carry bombs. It would be the bomb. The next morning, he raided the ordnance dump behind the hangars. Fuselage panels from wrecked aircraft, feed chutes from P-40 fighters, a pile of Brownings stripped from the crash sites. Each 50-caliber gun weighed 60 pounds, 27 kilos. Each required 250 rounds and electrical firing controls. Gunn found 8, then 10. The airframe could handle it if he reinforced the forward bulkhead and trimmed weight elsewhere. Remove armor plate behind the pilot, lighten the tail, balance the center of gravity with ammunition. His crew chief, Technical Sergeant Billy Cummings, tried to stop him. "You'll tear the nose clean off," Gunn smiled. "Then we'll bolt it back stronger." By late January 1943, the first prototype was taking shape. The bombardier's position disappeared under a cage of steel tubing. Ammunition boxes filled the forward compartment. Gunn welded improvised brackets for 8 forward-firing Brownings, 2 more in cheek mounts. Mechanics cannibalized electrical connectors from wrecked aircraft. They wired the triggers to the pilot's control column. One press and 10 guns would fire in unison, 120 rounds per second. He reinforced the nose floor with 6 mm steel plate, scavenged from a grounded transport. Adjusted the center of gravity by moving batteries aft. When they finished, the aircraft looked brutal. No glass, no bomb sight, just a blunt metal snout bristling with barrels. The test flight happened on a gray morning over Port Moresby. Gunn taxied the aircraft himself. No chase plane, no observers, just one man and an idea that might kill him. He lifted off, circled the airfield once, then lined up on a derelict barge anchored in the harbor. At 200 feet, at 60 mem, he pushed the throttles forward and fired. The recoil shook the entire airframe. Shell casings rained from the nose in a metallic storm. The barge erupted under hundreds of impacts. The guns held, the structure held, the pilot lived. When Gunn landed, mechanics ran to the aircraft expecting holes or cracks. They found none. The design had survived its own violence. He sent a message to 5th Air Force headquarters. "Test successful. Request permission for field modification of additional aircraft." No answer came for 2 weeks. Headquarters didn't know what to do with a bomber that carried no bombs, so Gunn kept modifying them anyway. Each night, sparks lit the hangar as torches cut and welded. One aircraft became 3, then 5, each version heavier, deadlier, more refined. The men called them Pappy's gunships. And the day the first of them met a Japanese convoy, every argument against him vanished in fire and salt water. The airfield at Townsville smelled of oil, wet canvas, and acetylene. Gunn's hangar had turned into a workshop of controlled mutiny. Every rule of maintenance procedure lay in shreds, tools scattered across benches, aircraft panels leaned against fuel drums. Mechanics who should have been asleep were cutting bulkheads at midnight, feeding a project that didn't officially exist. They called it Project 995, a number chosen to confuse supply officers. Its parts were requisitioned from destroyed aircraft, its ammunition drawn from depot overstock. Gunn kept a small notebook full of hand calculations, weight tolerances, recoil loads, airflow disruptions, electrical draw from 10 synchronized 50-caliber guns. He had no engineering team, no drafting table, only instinct and 20 years of mechanical memory. The first problem was recoil. 10 Brownings firing together generated nearly 2 tons of backward force. The nose structure of a B-25C wasn't built for that. Gunn welded cross braces from spare landing gear struts, tying the gun mounts directly into the fuselage ribs. He shifted the pilot seat slightly aft, moved the battery bank to the tail compartment, and cut the oxygen system to save weight. The second problem was ammunition feed. Each gun required 250 rounds. Belt jams at high speed could rip a weapon out of alignment or worse, trigger a cook-off. Gunn scavenged flexible feed chutes from P-40 fighters, lined them with steel guide plates, and improvised a deflector chute to keep empty casings from clogging the control cables. The third problem was electrical. The factory-installed firing system was designed for a single trigger circuit. Gunn rewired the entire nose section with parallel relays, allowing the pilot to control all forward guns with one switch on the yoke. He tested it with batteries connected to a crate of light bulbs. 10 lamps that flashed simultaneously when he pressed the trigger. The test worked. So did the guns. By the end of February 1943, the prototype rolled onto the tarmac. The nose was matte olive drab, seams welded over, gun barrels protruding like organ pipes. No bomb sight, no transparency, just a single armored plate with a slit for visibility. Gunn had painted a small line of white letters under the cockpit. Pappy's Folly. When the aircraft fired for the first time on the ground, the shock wave cracked 2 windows in the maintenance hut. The recoil rocked the bomber backward 1/2 meter. Gunn laughed. "If it moves," he said. "It's working." Flight tests followed. He flew low over the water, testing stability, firing speed, checking whether the nose pitched under recoil. It didn't. The airframe trembled but held course. Gunn recorded the data in a pocket notebook. Recoil deflection less than 2 to grain. Speed drop 6 knots during burst, elevator response normal. He landed, ordered the mechanics to add 2 more guns and cheek mounts, 12 in total now. The weight increase was marginal. The effect was not. The firepower matched that of a destroyer's secondary battery. Word spread through 5th Air Force, like a rumor no one wanted to believe. Crews from nearby squadrons came to see the Monster Mitchell. Photographs circulated, a blunt-nosed bomber with a forest of gun barrels. One intelligence officer called it a violation of the laws of aerodynamics. Gunn called it insurance. He submitted a field report to General George Kenney, commander of 5th Air Force. Kenney visited the airfield in early March, walked around the aircraft in silence, and asked the only question that mattered. "Will it fly?" Gunn replied, "It already has." Kenney authorized limited trials. 3 modified B-25Cs were assigned to the 3rd Attack Group, the same unit that had been losing men in fruitless anti-shipping strikes for months. Gunn briefed the pilots himself. "Forget altitude," he told them. "You'll fly at 200 feet, 60 mim. Don't drop, don't bomb, strafe the deck until there's nothing left moving." The pilots stared at him, half in disbelief, half in anticipation. They'd been flying suicide patterns for a year. At least this one gave them a chance to fight back. On March 3rd, 1943, the new gunships took off from Port Moresby at dawn. Their target? A Japanese convoy moving supplies toward Leh. 8 transports, 4 destroyers, fully armed. The standard bombers followed at altitude. Gunn's aircraft came in low, below radar, below expectation. No one had ever seen a B-25 attack like that before. When they returned, the sea behind them burned. And what those pilots reported that evening would change the entire idea of what a bomber could do. At 0710 hours on March 3rd, 1943, over the Bismarck Sea, Japanese lookouts aboard the transport Kyokusei Maru saw dark specks racing across the horizon. Too fast for torpedo bombers, too low for level bombers. The sea spray hid their approach until the first B-25s broke from the cloud base at mast height. Gunn's modified aircraft led the formation. The gunships came in at 240 knots, 445 kilometers H, just above the waves. Their propellers cut vapor trails through salt air. Japanese anti-aircraft crews struggled to traverse Gunn's downward fast enough. The first bursts of 25mm fire went wide. Then Gunn's lead aircraft opened fire. 10 50-caliber machine guns roared in a single, continuous blast. The forward deck of the lead transport turned white with explosions. Gun crews vanished under sheets of tracer impact. The second gunship followed 50 meters behind, raking the ship from bow to stern. Each second released 120 rounds. In 5 seconds, 600 rounds of armor-piercing incendiary tore through the ship's bridge, superstructure, and fuel drums. Witnesses described the attack as a solid beam of fire. It wasn't strafing. It was demolition at point-blank range. When the smoke cleared, Kyokusei Maru was burning from stem to stern. The convoy's formation collapsed as ships veered away from one another, scattering like prey. Higher above, conventional B-25s began their bombing runs. Gunn's experiment had become their shield. Japanese gunners focused on the low attackers, leaving the high-altitude bombers unmolested. The sea erupted with splashes of 500-pound, 225-kilo bombs dropped from 1,500 feet, 450 Mauer. Most missed, but it didn't matter. The gunships were doing the killing. The third modified B-25, piloted by Captain John Hennebury, lined up on a destroyer attempting to cover the convoy's flank. Hennebury fired a 5-second burst into the ship's bow. One engine exploded. The destroyer veered off course, its deck crew cut down before they could return fire. Hennebury banked away so low that salt water streaked his canopy. Other airmen watching from above realized what they were seeing. This wasn't a bombing run. It was naval gunnery from the sky. The idea spread instantly across radios. Follow Pappy's lead. Go low. Go in. The phrase Pappy's specials became shorthand for any aircraft modified to fight like his. By 0900, 4 transports were burning. 2 destroyers were crippled. The airfield at Leh recorded black smoke on the horizon stretching 20 kilometers out to sea. Japanese survivors would later write that they had never seen aircraft behave like that. Bombers diving in below the mast line, shredding anything that moved. Their anti-aircraft directors couldn't adjust fast enough. The guns fired over the attackers' heads while the real threat chewed them apart from below. Gunn's own gunship returned, with paint scorched off its nose from powder flash. The aluminum skin near the gun ports glowed faintly red. He'd fired over 1,800 rounds in a single sortie. The guns held, the mounts held, the idea held. When he taxied in at Port Moresby, ground crews swarmed the aircraft. Mechanics touched the nose like it was a relic. The pilots who followed climbed out covered in sweat and powder residue, eyes wide with the realization that they'd survived something that should have been impossible. Gunn didn't celebrate. He stood at the edge of the tarmac watching fuel trucks roll up and ordnance crews reload. The experiment was over. Now it was replication. That evening, 5th Air Force Intelligence compiled the battle damage assessment. 8 Japanese ships destroyed or crippled, 1/3 of an invasion convoy wiped out in a single morning. Losses among the attackers, minimal. The new doctrine, skip bombing combined with heavy strafing, had worked with mathematical precision. General Kenny cabled headquarters. Field modifications by Major Gunn contributed decisively to victory in Bismarck Sea engagement. Recommend immediate evaluation for standardized production. The report understated the reality. The engagement had rewritten the physics of the Pacific War. Bombers no longer dropped bombs from safety. They descended into chaos, survived, and destroyed their targets by sheer overwhelming fire. That night, in the Townsville hangar, Gunn drew new sketches under a single bare bulb. Heavier armor, better feed systems, nose hardpoints for even larger guns. The first success had proven the principle. Now he wanted perfection. And in pursuit of that, he was about to turn field modification into factory doctrine. Within weeks of the Bismarck Sea victory, the 5th Air Force turned Gunn's personal experiment into a regional industry. His hangar at Townsville became the unofficial gun shop. Pilots, engineers, and ordnance men crowded inside, sketching ideas on plywood tables stained with oil. Every returning B-25 seemed to arrive, missing its bomb sight, and carrying more guns than before. The Army's official design bureau at North American Aviation sent technicians to investigate what Gunn had done. They found structural modifications so crude they shouldn't have worked. Hand-cut steel braces, ammunition boxes welded directly to bulkheads, wiring spliced with signal cable from radio trucks. But the results were undeniable. General Kenny ordered a liaison flight to the U.S. mainland, carrying film of the March engagement and a full technical summary. Engineers at Wright Field watched the footage in silence as streams of tracer fire annihilated Japanese shipping. The report's final line read simply, "Recommend adaptation of this field modification for production aircraft, B-25G proposal." In mid-1943, North American engineers met with Gunn in Australia to standardize what he had improvised. They expected a wild-eyed amateur. What they found was a man who knew every stress point, fuel balance, and center of gravity equation on the airframe. Gunn spoke in numbers, not theory. He handed them sketches for a new nose assembly, armored plate-forward bulkhead, 0.5-inch, a 12mm steel sheeting, and 8 fixed Brownings in a reinforced gun block. He also wanted something bigger, a cannon. The engineers hesitated. Installing a 75mm M4 tank gun in an aircraft seemed impossible. The recoil alone could tear a Mitchell apart. Gunn disagreed. "Recoil is just force over time," he told them. "Stretch the time, absorb the force." He proposed a hydraulic buffer system, scavenged from a B-24 landing gear cylinder. The engineers tested it in simulation. Against their expectations, it worked. The prototype B-25G rolled out of North American's Kansas City plant that August. Gunn's fingerprints made metal. The new model carried a 75mm cannon and 14 machine guns. The bombardier's position was gone. The aircraft's job had changed. No longer a bomber, it was an attack ship killer. Field units called it the Flying Fortress for the Low Sky. Tactically, Gunn's vision expanded into doctrine. Fifth Air Force created composite attack squadrons, mixing standard B-25s for bombing with gunships for strafing. Flights approached at 500 feet, 150 men, skipping bombs across the water while gunships swept decks clean. Pilots called it mast height attack. Japanese convoy commanders called it suicide weather. Combat reports from mid-1943 tell the story. June, 2 B-25Gs destroy a destroyer escort near Cape Gloucester with 3 passes. July, 6 gunships attack a troop convoy north of New Britain. 5 transports sunk, no aircraft lost. August, strafing of Wewak Airfield. 40 Japanese aircraft destroyed on the ground in under 10 minutes. The psychological effect was immediate. Japanese merchant captains began sailing at night, hugging coastlines under camouflage nets. Anti-aircraft gunners recalibrated fuses for low-altitude targets. Even Zero pilots, once contemptuous of Allied bombers, now hesitated to engage B-25 formations. Their fighters lacked armor. A single burst from 1450 calibers could cut a Zero in half. Gunn's field shop didn't stop at the G model. His correspondence with North American led to the H variant. Improved cannon mount, automatic reload, lighter armor, better recoil absorption. The production line turned out hundreds. His illegal modifications had become U.S. Army Air Force's standard. But technology was only half the story. The other half was what it did to the men who flew them. Pilots who'd once bombed from safety now dove into anti-aircraft fire at treetop height. Their confidence grew with each mission, built on visible results. They could see their fire tearing into ships, see explosions ripple outward, see the ocean burn. For the Japanese, it was a new kind of terror. Bombers that attacked like fighters, too low to intercept, too fast to track. For the Americans, it was proof that innovation could come from the bottom of the chain of command, from a man who didn't ask before changing the rules. The factories built thousands, but the blueprint was born in one hangar under tropical rain. And as those gunships spread across the Pacific, they carried not just weapons, but the defiance of the man who had built them with a torch and a conviction. By late 1943, Japanese naval intelligence began recording a new phrase in intercepted radio messages. Heavy strafing from low-flying bombers armed with many machine guns. They didn't have a name for the B-25G or H yet. Crews simply called them the Gunn monsters. Their reports told a consistent story. Convoys shattered before completing their runs, airfields erased in minutes, coastal batteries wiped out by bombers that didn't bomb. At first, the Imperial Navy believed the encounters were isolated, overzealous pilots flying suicide tactics. Then came the data. Between March and December 1943, ship losses in the Bismarck and Solomon Seas doubled. Every incident included the same line. Attacked by low-level bombers firing continuously. Survivors described the noise before they saw the aircraft. A thunder of synchronized guns that grew louder until the sea itself seemed to shatter. On the decks of transports, men abandoned their posts, diving for cover as hundreds of armor-piercing rounds walked from bow to stern. Officers wrote that morale had collapsed long before the explosions began. For the Japanese, the shock was not just material, but psychological. They had built a doctrine of superiority, fighter speed, disciplined gunnery, precision maneuver. Gunn's invention destroyed that equation. His B-25s didn't fight by their rules. They erased the rules entirely. Intercepted diary pages from an officer aboard the destroyer, Horatio captured the feeling. They come like madmen. They fly so low their shadows touch the water. There is no warning, only fire. We shoot, but it makes no difference. The 5th Air Force collected similar stories from prisoner interrogations. Japanese gunners complained they could not see the attackers until tracers were already striking the deck. Others reported the psychological paralysis of being hit by aircraft that never seemed to climb, never broke off, only kept coming. American pilots noticed it too. They saw gun crews abandon their weapons, watched ships zigzag wildly until they collided. B-25 units started referring to these moments as panic runs. Some pilots even admitted they no longer needed to aim carefully. Fear did half the work. Back at Townsville, Gunn followed every report, noting how behavior changed faster than hardware. The fear his design produced was a weapon as real as any bullet. He understood that technology wasn't just performance, it was presence. The sound of 10 Brownings firing together had become a form of psychological warfare. In squadron briefings, pilots began to talk less about tactics and more about rhythm. The precise moment to begin firing, the angle of approach that created maximum terror. One captain compared it to conducting an orchestra of destruction. When asked about it later, Gunn said quietly, "If they're too scared to shoot back, you've already won." By early 1944, the Japanese response had shifted from defense to avoidance. Convoys traveled under cloud cover or only at night. Merchant captains requested fighter escort for routes once considered safe. Entire supply chains slowed, strangling garrisons across New Guinea. The American crews who flew the new gunships were different men now. They had watched ships disintegrate under their fire. They had watched enemies abandon weapons and run. The emotional tone in debriefings changed, from frustration to a grim satisfaction. Gunn's machines had given them control of the sky, but also a new kind of burden. One pilot wrote after his 23rd mission, "We used to pray for accuracy, now we pray for restraint. The gunship doesn't miss." Even the Japanese Army's Psychological Warfare Bureau took notice. Translations of American field reports were distributed among naval commands with red ink warnings. Do not engage low-flying B-25 types directly. Maintain altitude advantage. Avoid entanglement. By then, avoidance was impossible. The gunships struck airfields, bridges, convoys, coastal bases. They arrived without warning, left before interceptors could scramble. And every time, they carried the same invisible signature. Gunn's defiance welded into their frames. Fear had become strategy. And behind every mission report, every burned ship, there was still the old man in the hangar, turning field modifications into a weapon of belief. By 1944, the numbers told a story even headquarters couldn't ignore. Before Gunn's modifications, 5th Air Force anti-shipping missions averaged 1 vessel sunk for every 40 sorties. After the introduction of gun-equipped B-25s, the ratio dropped to 1 for every 8. In the Bismarck and Solomon Seas, Allied bombers had transformed from harassers into predators. Monthly loss reports from Japanese Naval Command read like casualty lists for convoys. March 1943, 8 ships destroyed. June 13, September 17. By year's end, more than 150,000 tons of shipping lay at the bottom of the Pacific, most sent there by aircraft, whose designs had begun as unauthorized sketches in Gunn's tent. The Army Air Forces measured success differently. Before the gunships, attack groups in New Guinea suffered loss rates approaching 12%. By mid-1944, those same groups, now flying mixed formations of cannon-equipped B-25Gs and Hs, reported under 3%. Fewer pilots died. More missions finished. Supply lines to New Guinea's front lines stabilized for the first time since 1942. Commanders who had once called Gunn reckless now quoted his statistics in staff meetings. General Kenny's official after-action summary credited him directly. Major Gunn's field ingenuity and armament modification has reduced attrition and increased offensive output beyond prediction. Tactical flexibility is now the decisive advantage of our medium bomber units. In factories across the United States, engineers followed the same hand-drawn measurements that Gunn had scribbled in pencil months earlier. The B-25H rolled off the Kansas City production line with 14 guns and a 75mm cannon. Its forward battery could deliver 5,000 rounds per minute, equivalent to the combined firepower of an entire fighter squadron. Maintenance manuals that once warned against low-altitude attack now included illustrated pages showing mast height approach procedures. The once illegal concept had become official doctrine. Gunn's signature appeared on the technical reference for forward-firing armament installations, a bureaucratic acknowledgement that the Army had finally caught up to his heresy. He didn't slow down. When assigned to Maintenance Command in Brisbane, Gunn used the post as another workshop. He experimented with rocket rails under B-25 wings, twin cannon mounts, and new armor layouts. He corresponded directly with North American's engineers, bypassing layers of command entirely. The relationship between field and factory had never been closer. In raw terms, the transformation was staggering. Between 1943 and 1945, Allied B-25 units in the Pacific flew 25,000 combat sorties, destroying or damaging more than 200 Japanese ships. Gunship variants accounted for over 60% of those kills. In comparative tests at Eglin Field, Florida, the B-25H outperformed every other medium bomber in sustained fire capability and target destruction rate. But numbers could only hint at the human cost avoided. Every transport sunk meant fewer Japanese reinforcements reaching the front, fewer Allied soldiers facing ambushes on jungle trails, fewer names added to casualty rosters. Every mission completed meant 9 men returning instead of 9 funerals. Historians would later write that Gunn's innovation shortened the New Guinea campaign by months. It saved thousands of lives without ever being planned, budgeted, or formally approved. All because one man refused to follow instructions written for a different kind of war. Even after mass production began, pilots still asked for Pappy's original. They trusted the field conversions more than factory versions, believing the hand-built frames carried some of his stubborn magic. Mechanics in forward bases painted "Gun Shop Special" on modified aircraft in block letters, a quiet acknowledgement of their origin. In Japan's naval archives, captured after the war, analysts found a chilling summary dated November 1944. American B-25 type has changed character. No longer a bombing aircraft, it is a strafing ship of great destructive power. Defensive preparations ineffective. That line marked the end of an era, the point when innovation from a single hangar forced an empire to rewrite its defensive doctrine. By then, Gunn had already moved on to his next problem, adapting other bombers, pushing for rocket ordnance, dreaming about what came after the war. He never spoke of legacy. He spoke of efficiency. If it works, he said, it belongs in the sky. But what he left behind was more than an aircraft. It was a blueprint for rebellion, measured in kill ratios and lives saved. By 1945, the Pacific was changing faster than any doctrine could keep up. Carrier fleets ruled the sea, long-range fighters escorted bombers deep into enemy territory, and the age of the single pilot tinkering with strategy seemed to be over. But in hangars across the islands, the ghost of Paul "Pappy" Gunn lingered in every modification that didn't come from a blueprint. He never held high rank, never commanded squadrons. His power was simpler, proof. He had shown that a mechanic's logic could beat a general's theory. The 5th Air Force credited him for the B-25G, and H. North American Aviation credited him for practical design suggestions on the A-20 Havoc, and even the early concept for the A-26 Invader's nose battery. But none of those official acknowledgments mattered to Gunn. He lived for results, not recognition. In late 1944, while testing a modified aircraft near Clark Field in the Philippines, his B-25 crashed during landing. He was pulled from the wreckage, bruised but laughing. "It'll fly better next time," he told his crew. A year later, in October 1957, another aircraft went down in Alabama. This time there was no next flight. The man who had made bombers bite the ocean died at 58, still flying, still refusing to retire. History often forgets men like Gunn because they don't fit into neat categories. He was neither pure soldier nor engineer. He existed between the mechanic who thought like a pilot and fought like an inventor. The field reports called him a technical advisor. The pilots called him Pappy. The truth lay somewhere in between. He was the hinge between failure and adaptation. The legacy of his work wasn't just hardware. It was attitude. Every forward depot that learned to weld armor instead of waiting for shipments carried his DNA. Every airman who ignored a manual because he trusted experience over regulation echoed his defiance. Even after the war, when jet aircraft replaced propeller bombers, the idea that innovation could begin in a dirt floor hangar stayed alive. In the Pacific, victory had many authors: industrial might, logistics, strategy. But somewhere in the shadow of those vast equations was a man with grease on his hands and an idea so simple it bordered on heresy: that survival depended not on obedience, but on imagination. Historians sometimes debate how much his gunship contributed to the overall outcome. The numbers are clear enough: hundreds of ships destroyed, thousands of tons of cargo denied to Japan, countless missions completed with lower loss rates. Yet the real transformation was psychological, a shift from passive defense to aggressive adaptation. Gunn's vision changed how pilots saw themselves. They weren't just operators of machines, they were engineers in motion. In an after-action summary, a pilot once wrote, "We were taught to follow orders. Pappy taught us to fix them." Maybe that's what victory really looked like in the Pacific. Doctrine rewritten in torchlight. Policy bent to the will of survival. Gunn's gunships didn't win the war alone, but they made sure it could be won faster, with fewer names carved into marble. The official histories close his chapter with a brief line: Major Paul Gunn, pioneer of low-level attack tactics, instrumental in development of B-25 gunship variants. It reads clean, efficient, bloodless. The truth was louder: 10 Brownings firing in unison over the Bismarck Sea, an old man at the controls proving that genius sometimes looks like disobedience. Maybe victory in the Pacific began with one man who refused to read the manual. If you've watched this far, you've heard the proof that invention in wartime rarely starts at the top. It starts in the mud, in the hangar, in the hands of people who refuse to fail. Comment below. Was Pappy Gunn a genius, or a madman who got lucky?